Hi students, in this video we'll learn about how we're going to employ the new parameter of moles. We've already discussed pressure, volume, and temperature. Now we'll incorporate our measurements of moles for gases and we come up with Avogadro's law. We're familiar with Avogadro because he is the one who brought up the concept that 1 mole is 6.022 times 10 to the 23rd particles. Here we'll be learning his law in gas laws. So essentially, Avogadro's law is as I increase the number of moles of a gas at constant pressure and temperature, the volume would increase. So this kid's blowing in a balloon at constant pressure and temperature. If he blows more air in this balloon, the balloon's volume would increase. So that's essentially Avogadro's law. As the number of moles of a gas increases at constant pressure and temperature, the volume must also increase. What does that mean? That volume and moles, the number of particles, are directly proportional if I have constant temperature and pressure. So if the number of moles goes up, so does the volume. Again, you can use that simulation, that PhET simulation that we've been working with so far, and we can see this in this example right here. So I'll put in a couple of particles. Let's do 100. And right now we notice I'm currently at a temperature of 300 Kelvin. I'm at a pressure of 23.4 atmospheres. If I put double the moles or double the particles, my pressure goes up because I haven't compensated for the volume. But if I want to have that constant atmospheric pressure of 23.4, which it was before, because I doubled the number of moles, I must double the volume. So I need to bring this instead of to 5 to 10. And now I see the pressure is back to where it initially started and the temperature remains the same. So my pressure and temperature has remained the same, but I doubled the number of particles. And for pressure to remain the same, remember, pressure is the number of collisions per unit area. The only way to have the same number of collisions, if I have twice the number of moles, is I have to twice the volume, which is what I did here. So going back to our slides, it makes sense. And now I see it in my PowerPoint. If I double the number of particles, then the volume has to double as well. And I have this ratio because they are directly proportional. Again, doubling the number of moles doubles the volume. So I can apply this to calculations. And just like before, as I read the problem, I can label. So if 0.75 moles, these are my initial moles, of helium gas occupies 1.5 liters, that's my initial volume. What volume? Okay, I'm looking for a change in volume. I'm looking for the final volume, V2. Will 1.2 moles, okay, I've increased the moles. So if I increase the moles and temperature and pressure are constant, the volume must also increase as well. So V1 over N1 equals V2 over N2. I plug in my values, and if I multiply both sides by 1.2 moles, 1.2 moles, on my left side, I see the unit of moles are left, and I'll have liters as my final unit. On the right side, this entire value in unit cancels, leaving me with just V2. And I see that my final answer for V2 is 2.4 liters, which makes sense because again, I increase the number of moles, so the volume must increase if I want pressure, the number of collisions, to remain the same on the walls of the container. So I hope this video helps you understand the concept of Avogadro's law and how volume is directly proportional to the number of moles of gas at constant pressure and volume, or constant pressure and temperature. Thanks so much.